So today we'll start with behavioral modeling style. Okay. Uh, so, behavioral modeling, if you take first class, I told you, there are four types of modeling styles like switch level modeling, gate level modeling, data flow modeling, and behavioral modeling. Okay, behavioral modeling. So behavioral modeling means like in behavioral modeling, I will not do I will not care about the internal circuitry. Just I will see only behavior of the circuit. Suppose if you consider half adder circuit, what this half adder will do, it consists of two inputs and two outputs, and it will do the addition, and it will give the sum and carry only. Like that will do only behavior of the circuit. That will it will add two numbers only. Okay, that is the behavior. Okay. In this first we'll study about structural procedures. Structural procedures. Okay. So you have like procedural blocks. Okay, procedural block. In the procedural blocks, basically we'll study about initial block, and next is always block, initial block and always block. Okay, so first we'll see the initial block. Okay, so initial block. What is this initial block? So initial block is initial block. This will execute only one time. This will execute only once, only once, and stops when reaches the end of the block. Stops when reaches the end of the block. Okay, end of the block. Okay, so this is non-synthesizable. Means what? This is non-synthesizable. Non-synthesizable means we cannot convert into hardware. First class I told you, no, we cannot convert into gate level netlist, or we cannot convert into hardware. Okay, that is non-synthesizable. Initial block is non-synthesizable. Then where we are using means we are using this one in test bench. Initial block we are not using in the design, we are using in the test bench. Okay, did you understood? So that means next you have always block. So always block, if you take, so always block means what? This repeats continuously throughout the duration of simulation. Repeat. The what is the meaning of always? Continuously, no? Repeat continuously throughout the duration of simulation. Duration of the simulation. Okay. So this is always block, and always block is the essential element of RTL behavioral modeling. Okay. This is always block is this is the essential element for RTL behavioral modeling. Behavioral modeling. Okay. So next, suppose if there are group of statements are there. Okay. So block of statements are there. We need to write between the begin and end. Okay. If one statement is there means so no need to write between the begin and end. Suppose group of statements are there. So that means we should write between the begin and end. So suppose this is statement one. Okay, and next you have statement 2. Okay, next you have state 3. Multiple statements are there means we need to write between the begin and end. Okay, if multiple statements are there means you need to write between the begin and end. This begin is a keyword and end is also keyword. Okay, is it fine? Okay, yeah. So suppose uh, suppose if you take initial block, so how to write? So the block so that means this block start with the keyword initial. initial, and it will start at what simulation time. When you write simulation, it will start at 0 times 0 simulation time. Okay, 0 simulation time it will start. Okay, so suppose example, if I write like this: begin reset equal to one tick binary 1. Okay, and I'm giving some delay. After 10 time units, I'm making reset equal to what? Reset equal to one tick binary 0. Okay, and next what I am doing, I'm giving in equal to 2. Okay, and after 10 time units, what I am doing, in equal to 3, in equal to 3, and like this I can write. Okay, so that means it will execute. That means it will stop execution when last statement. So when it is come to end, it will stop execution. It will execute only one time. Okay. Suppose if you want to write in test bench, so like this I can write. That is module, and my module name is test bench. Okay, and yeah, module name is test bench. So how to write reg A comma B. Okay, I'm declaring reg A comma B. Initial begin. So what I am declaring, I am A equal to one tick binary 0, and B equal to one tick binary 0, 0, and after 10 time units, what I am doing, after 10 time units, I am giving A equal to one tick binary 1, and after 10 time units, I am giving B equal to one tick binary 0, and end, and I can write initial. So if it is one statement, no need to have initial. So 100 units, I am making A equal to one tick binary 0, and initial. So I am giving hash 500, that is 500, and I want to run dollar finish. Dollar finish is a system task. If you want to stop the simulation, I can use dollar finish and end mode. Like this, you can write in the text page. Okay, yeah. So this is about the initial block, and next you have always block also. Always block means what? Yeah, repeated continuously. So always block, how to write means uh, always block. So always block. This is you have a loop that is controlled by the events. Controlled by events. Okay, or we can call as sensitivity list also. Sensitivity list. Sensitivity list. Okay, so that means here, mm, so it will start with a keyword. Always will start with a keyword. What is the keyword you are using? Always is a keyword. Okay, event, a change in the value on register or a net. Okay, so that means or suppose if you take one half adder circuit. Okay, so half adder circuit, how to write? I'm declaring, suppose I'm declaring the so module half adder. Okay, half adder, I'm declaring input a comma b, and output some comma carry. Okay, so I'll write always. What is the sensitivity list? At the rate some comma carry. This is sensitivity list. If there is, I'm sorry, always at the rate a comma b. If there any change in the input, there is change in the output. That is begin. Sum equal to what? I need to write a XOR b. And carry equal to what I can write? A and b. Bitwise operator. Okay. End and end module. Like this, I can write the simple code for half adder circuit using which modeling? Behavioral modeling. Okay. Suppose if it is for the D flip flop, if you want to write, so how to write means this will be execution triggered on passage of clock. Let us take whatever the execution is there, that will be triggered on passage of clock means I'll write this at the rate. In the sensitivity list, what I can write? Passage of clock. Passage of clock. Begin. Begin. If reset equal to 1. If reset equal to 1. Q I am initializing to what? 1 tick binary 0. Otherwise, else Q is initialized to D. Okay? End. Like this. Did you understood how I am writing? So that means here, so the syntax will be like this. So how the syntax will be there? Syntax will be always, always at the rate triggering signal. You need to indicate triggering signal. Okay, triggering signal and begin. You need to use procedural statement. Procedural statement and you can use procedural assignment. Procedural assignment. Okay, procedural statement and procedural assignment and end like this in it. Okay, suppose suppose your design have some 100 inputs are there. Okay, or 100 inputs or your design have some 200 inputs. So 200 inputs you can't declare in the sensitivity list, no? So 200 inputs you can't define. So in this situation, you need to use a operator called implication operator. Impli, okay, implication operator. Okay. What is this implication operator? Star. Star is the implication operator. So that means always how to write at the rate star. Star means what? Any number of inputs. If there any change in that input, then that is change in the output. This will be applicable for all the inputs. Okay, so we can indicate implication operator in the sensitivity list. Okay, suppose here I am writing. I have how many inputs means four inputs are there. So here I can write out equal to. So here I can write A R B and C and XOR of D and end like this I can. Did you understood how I am doing? Okay, yeah, this is about the always block. Okay, and next coming to the procedural statements. What are the procedural statements? So we see the procedural assignments. What are these procedural assignments? What are the initial and always blocks? Okay, these are the procedural blocks or structural blocks. Okay, so procedural statements. What are the procedural statements? So procedural statements. So these are like it determines the flow of data and operation. Okay, procedural statements determines the flow of data and operation. Okay, and operation. So first you have conditional statements. What are conditional statements? In C you already studied, I think so. You have if else, case. These are conditional statements. Okay. Next you have looping statements. Looping statement. What are looping statements? You have while, for, repeat, okay, forever. These are the looping statements. Is it fine? Okay. So suppose if you take, I will take one more page. So if you take if else condition, so if else condition if you take, the syntax will be like this. So syntax will be, so if you take if else condition, the syntax will be like this. Syntax is if condition, if condition begin, begin, code to execute if condition is true. Code to execute if condition is true. Okay. End. Else, else begin, code to execute, code to execute if the condition is, if condition is false. Okay. End. Okay. So that means what? If condition is true, it will execute true condition. If condition else, if condition that means else it will execute which condition? False condition. Did you understand? Suppose for this I am writing one example. Suppose module. I am writing for which one means 2 cross 1 marks. Okay, I am writing the example for what? 2 cross 1 marks. How many inputs and how many outputs and how many selection line? 2 inputs, 1 selection line, and how many outputs? 1 output. Yeah. So I'll write module mux. What is my module name? Mux. I need to declare input and output. No, input A comma B, and what is my output? Output Y. Okay. So if I am not declaring any data type, so it will take as which data type? Y data type. Okay. It will take as Y data type. So how to write? Always at the rate sensitivity list. What is the sensitivity list? AR, BR, yes. Okay. Okay. So I write begin. I'm using if statement. If selection line S equal to 1 tick binary 0, Y equal to what? A. Okay. Else Y equal to B. End and end more. If you can try in the Vivado or Vivado also, you can try. Okay, you try and you elaborate the design. Then just tell me how the circuit you are getting. 2 cross 1. Okay, and next is what? Next is yeah, looping statements. And next if else statement. One second. If else statement, you have case statement also. In the conditional statement, if else and case also there, no? Case. So I told with if else statement. Okay, for mux if else statement. Okay. So next I will show with the case statement. Okay. So if you see the case statement, the syntax will be like this. Case statement. The syntax will be like this. Case syntax. Case. Okay. Selector. Case selector. Value 1. Value 1. Code for value 1. Okay. And next value 2. Code for value 2. And next up to so on. For case statement, you have default statement. Okay. So why it is default? Default is why in the case default is required means when I explain this test bench, I will explain this. Okay. So till now you remember that for case statement you have a default statement. Okay. So this is what code for default statement. Default case. Code for default case and end case. Did you understand how I am doing? Okay. So for this, if I take same example, so I am taking which example? 2 cross 1 marks. Okay. So if I take 2 cross 1 marks, So that means what are the inputs? A and B. What is the output? One. And one more select. Okay. So I'm writing for 2 cross 1 maxima using case statement. So how to write module? What is my module name? Mux. Okay. I need to declare input A comma B and output output Y. Okay. One second. Here, if you are using behavioral modeling, if you are using procedural statement, you need to use output as reg data type. You need to use as what? Reg data type. Okay, this is number. Okay, output should be which data type? Reg data type. Why? Because you are using procedural block, no? Okay, so when you are using procedural block, that too in behavioral modeling, you need to use the output as reg data type. Port rule connections we already seen. Okay, just to go through that port rule connection. So always I'm writing always block always at the rate. Uh, I can give star also, no? Sensitivity list. In place of A comma B comma yes, I can give star also. Implication operator, I told you, no? So begin. I'm using yes, case yes. If it is zero, which is connected, A is connected. So that means Y equal to what? A. Okay. 1. If it is 1, which is connected, A is connected. So that is Y equal to what? B. Y equal to B. And what is the default statement? Default statement Y equal to 1 tick binary X. Okay. Why it is default statement means if you are not using default statement means it will infer as a latch. Internally it will take as latch. Okay. So in order to avoid that infer as a latch, that means latch we already seen in the sequential circuit. No, there is a feedback will be there. No, for the latch. Okay. In order to avoid that inferring as a latch, we need to use the default statement. Okay. And next end case and end module. Did you understood how I am writing for the case statement? Okay. And next next you have while statement, looping statement. In the looping statement, you have while statement. Okay. While statement, looping statement. In this first you have while statement. So the syntax will be like this. Suppose if you take while condition, you are checking for the condition. While condition begin. Okay. Here you can write while condition uh, begin. Okay, code to repeat while till the while condition is true. Okay, code to repeat while condition is true. While condition is true. Okay, end. Okay, so for this we will see one program. So for while condition, uh, so I am writing the code for while condition. uh, I am declaring one integer I, and I am initializing I equal to what? 0, while I is less than 0. Okay, begin dollar display I equal to what? Percentage D I. Okay, I equal to I plus 1. Okay, end. What it will display? Tell me. First you are initializing I equal to what? 0. Okay. So you are checking for whether I is less than 0, less than 1 second, less than 10. I is less than 10. Is condition is true or false? True, no? Condition is true. Begin, this will display. Okay. After that, I is incremented. So I is incremented. Is I is less than 10, condition is true. Again, this will be displayed. Okay. After that, I is incremented. That means I becomes true. Again, this is condition is true. That means that will be displayed. So that I will be displayed from where to where, 3, 4, 5, 6, 7, 8, 9. From 0 to 9, I will be displayed. Till this condition is true, the I will be displayed. Did you understand? Okay. This is till the while condition is true, this code will be in the looping statement. Okay. So remove the looping statement. Okay. So yeah. So this is the while condition. And coming to next, for loop, for loop. Okay. So for loop, the syntax will be like this. Suppose for I equal to 0, I is less than 8, I equal to I plus 1, begin. This is code to repeat 8 times. Code to repeat 8 times and end. Okay. So initialization is happening. I equal to 0, I less than 8, I equal to what? I plus 1. Begin code to repeat how many times? 0 is repeated, no? 0 to 7. That means how many times it will be repeated? 8 times. Okay. So we'll see with one example. Suppose, so code we'll see. For I equal to 0, I is less than 8, I equal to I plus 1, and begin begin y of I equal to what? C of I. Y of I equal to C of I and end. Okay. So that means first, what happens? First I equal to 0. Okay. I becomes 0. Is I is less than 8? Checking for the condition. Okay. True condition. So begin, I will be incremented. After that, so y of 0 equal to what? C of 0. It will display. Okay. After that I will be incremented. I becomes 1. Checking for the condition. I is less than 8. Yeah, true condition. Again, y of 1 equal to what? You will get C of 1. So up to so on like this, up to y of 7 equal to C of 7. If you want to display, this will be displayed. I think for loop. This is what for loop. Okay. Yeah. Next, mm, next, repeat loop. Repeat. Let us take the syntax for repeat loop. Syntax for repeat loop. Repeat 3. Begin. Repeat. This is 3. Repeat. This is 3. Okay. Repeat 3. Uh, code to repeat. Uh, so repeat. Code to repeat. How many times? 3 times. 3 times and end. Whatever the value you are replacing in the repeating bracket, that many times the code will be repeated. Understood? Suppose, let us take the code. If you take code, repeat 7. Okay. Begin begin y of I equal to what? C of I. Okay. I equal to what? I plus 1. Okay. End. So normally it will start from where? 0. Okay. So that means it will execute y of 0 equal to C of 0 and y of 1 equal to C of 1. Okay. So on y of 7 equal to C of 7, like this. It will be repeated for how many times? 7 times. Yeah, I equal to I plus 1. No? So 0 to 7 means it will be executed for 8 times. Okay. Yeah, yeah. So this is what repeated. Okay. And next, last is forever. Last is what? Forever loop. Forever loop. So forever, if you take, that means a statement to be repeated indefinitely. Forever means what? Statement, whatever the statement, okay, statement to be repeated indefinitely. indefinitely. Okay, so forever means here how to write means for the forever I will write one code. I'm generating the clock. Okay, so to generate the clock I can use forever to generate the clock. Okay, I'll write in next page. Okay, one second. So I'm writing the code for what? Generating the clock. Generating the clock by using forever. Okay, generating the clock. So how to write? Suppose module clock underscore generator and underscore tb. This is for I am writing in the text bench. Reg clock. Okay, reg clock initial begin. I am declaring clock equal to what? 0 forever and hash 5 clock equal to what? Hash 5 clock equal to not of clock. Okay, end and end. Okay, so that means here you are generating the clock. So that means suppose time scale is 1 nanosecond for precision is 1 picosecond. So you are generating the clock for how many? That means this is 5 nanoseconds, and you are generating for off for 5 nanoseconds and on for 5 nanoseconds. Total time period is how much? 10 nanoseconds. Okay. What is the frequency? Frequency is 1 by 10 nanoseconds means you are getting around 100 megahertz. 100 megahertz. Okay. So this we'll see with Vivado tool. Did you understood forever loop? Okay. Forever loop must be used carefully with timing control in order to prevent unintended infinite loops. Okay. Yeah. So this also we can see in the Vivado and you can generate the clock. Okay. You will try or shall I show this? No, you will try. Okay. So this is about forever loop and simple. So suppose simple code. I'll write the full adder circuit. Let us take the full adder circuit. I am writing using behavioral modeling. Full adder circuit have how many inputs in digital? We already discussed. Three inputs. Three inputs A, B, and carrier. Okay. And how many outputs? Sum and carrier. Okay. So I need to declare. That means module input. I need to declare module. And what is the module name? I need to use identifier. No. Let ladder. Module name is FA. And I need to declare input A comma B comma uh, carry in C in. Yeah. Output. Output. If you are using behavioral modeling, I need to declare with what? Reg data. Reg sum comma C out. Sum comma Z out. Okay. So this is a style to no. Style to no. This one. Style to means what? We are declaring the inputs and outputs in the bracket. So first I told you style 1 and style 2. Style 1 means first you need to declare the ports and separately you need to declare the inputs and outputs. Okay. And I'm using always block, always at the rate, at the rate sensitivity list I need to use. A, R, E, R, carry in. A, R, B, R, carry in. Begin, begin. Sum equal to what? A, R, B, R, C. Okay. And carry out equal to A and B. We already seen in digital, no? Sum equal to what you got? XR, BXR, C in you got, no? And carry out equal to what? AB plus BC plus AC in. Okay. BC in plus AC in. Okay. So that is A and B or between R and AND. Okay. B and C in or A and C. end end module. Did you understood how I am writing the code? Okay. And next you have uh, types of assignments. Okay. So what are the types of assignments? First you have blocks, procedural statements, or we can procedural blocks we discussed. In the procedural blocks, what are there? Procedural, structural procedurals or procedural blocks. Those are initial block and always block. Next, we discussed about the procedural statements. In the procedural statements, you have conditional statements. There are if else, case, looping statement, while, for, repeat, and forever. We already discussed. Next, we will discuss about types of assignments. Types of assignments. Types of assignments, if you take, so you have continuous assignment, and next you have procedural assignment. Continuous assignment and procedural. Okay, so that means continuous assignment means we already seen in the data flow modeling. No, first we will see the continuous assignment. Continuous assignment. Okay, so continuous assignment, if you take, actually like so mainly it will we'll use we assign the values to nets. Assign the values to nets. Okay, values to nets means what? Bytes only, no, wide data type, wide. Okay, this assignment occurs whenever the value of RHS changes. This assignment occurs whenever the value of RHS changes. Okay, this will execute parallelly. This will execute parallelly. So as I told you, Verilog is a which language? Concurrent language. Concurrent language means what? So it will execute parallelly. Okay. And next, this is continuously active. Continuously active. Okay. So what is the syntax for this one? Syntax is I need to use a keyword called assign. Continuous assignment statement, assign, and assignment statement. Assignment statement. Okay. Example is, did you understood what is continuous assignment statement? Okay. So in data flow modeling, we are using this continuous assignment statement only. We already completed with data flow modeling. So data flow modeling, we use this assign statement only. Okay. So suppose if I write the code for half adder circuit by using this continuous assignment statement, how to write? I think you already wrote the half adder circuit, no? Module half adder. I need to declare input x comma y and output sum comma carry out. Okay, so such a way that all the inputs and outputs should be wide data type. Okay, so in the continuous in the data flow, this is actually data flow modeling only. So first I told you, know, when you are writing in data flow modeling and behavioral modeling, that is said to be we call as RTL, register transfer level. This is synthesizable. This is what? Synthesizable. That means we can convert our code into gate level netlist. Okay. So here you see assign. I'll use continuous assignment statement. Assign sum equal to what? X XR Y, no. Assign carry out. Just I'm writing in terms of expressions only. X and Y. In half adder circuit, sum equal to what? A and B. A XR B, no. Carry out equal to what? A B, no. We already studied in digital. Okay. So next in the model. Yeah. Did you understand? Okay. Yeah. And procedural blocks, procedural blocks. So procedural blocks, if you see, procedural assignment, procedural assign, procedural assignments, if you take. So this provides a value to the variable such as what reg or integer type. This will provide values to the variable, such as what, such as reg or integer type. Okay. uh, do not change their value until the next procedural assignment. Okay. So do not change their value until next procedural assignment. Okay. So that will do not change that value until next procedural assignment comes. Okay. And next that means where we are using, these are used inside structured procedures. What are the structured procedures we already seen? Proceed, or we can call as procedural blocks. We can use in the initial block, always block, or we can use in the functions, or we can use in the task. We'll discuss what are functions and tasks. We'll discuss. Okay. And there are two types are there. One is blocking assignment, and next one is non-blocking assignment. Okay, non-blocking assignment. Okay. So every interview have this question: what is the difference between blocking assignments and non-blocking assignments? Okay. So blocking assignment means what? So that means when this instruction is executing, other instruction is said to be in blocked state. Okay. So first, this is very important. So without this, interview is not there. Compulsory they will ask. Okay. So like blocking, first we will see the blocking assignment. Blocking assignments. Okay. So how to write the blocking assignments? So blocking assignments. Suppose this execution of next instruction will be blocked until the current statement is executed. Okay. So execution, we'll see in the next page. Till now, is there any doubts or queries? Shall I move forward? Yeah. So this is very important. Okay, you go through this concept. So interview point of view, so blocking and non-blocking assignment. Blocking assignment. Okay, blocking assignment. The symbol is this one, equal to. Okay, equal to. Okay, and so execution execution of next statement execution of next statement is blocked until the current statement is executed. Until the current statement is executed. Okay. So that means it will be executed sequentially. Okay. Is executed. Okay. So if one instruction is executed, so until, so when that is in execution state, so next other instructions will be in blocked state. Okay. That means executes multiple statements sequentially, as I told you, no, executes multiple statements. Whatever the multiple statements are there, so multiple statements that will be executed sequentially. Okay, sequentially. Okay, so any delay attached to also got added to the delay and execute next instruction. Okay, suppose any delays are there. Okay, so any delay attached, also got added to delay, in the execution of next statement. Suppose like you can correlate with a real life example. Suppose single line road is there. Okay, so that means there is no chance of overtaking the vehicles, or you can consider toll gate. Okay, is there any chance in the overtaking in the toll gate? One after the car, one after the other, the car will move. So that means after exiting one car only, next vehicle will move. So that is we can correlate with what blocking assignment. Did you understand? Okay. So that means one way road, that is blocking assignment. So example for blocking assignments. Okay. So integer, other side the vehicles will not come. No. Suppose toll gate is there. The other side will the vehicle will come, not come. No. So that is the blocking assignment. So initial begin. Suppose I am giving x equal to 5. Okay. Equal to. Okay. So y equal to 10. And I'm declaring, okay, I'm declaring these variables, okay, z equal to what, z equal to 15, okay, I'm declaring. After that x equal to what, y plus z, okay, and y equal to x minus y, okay, and z equal to what, x plus y. Order is important. That means first this will be initialized, okay, this will be executed, and after this will be executed, okay, after this will be executed, after this will. So when this is executing, remaining will be in which state? Block list, state. Okay, so this is blocking assignment. Okay, and did you understand blocking assignment? Any doubts or queries? Yeah. Next, non-blocking assignments. Non-blocking assignments. Okay, so non-blocking assignment mostly like for designing the combination circuits we'll use blocking assignments. This you remember. For designing the combinational circuits, okay, combinational circuits, we use what, we use blocking assignments. Okay, and for designing the sequential circuits we'll use non-blocking assignments. Okay, non-blocking assignment, the symbol is this one, less than or equal, non-blocking. Okay, so that means execution of next statement is not blocked until the current statement is executed. Okay, it will execute parallelly. Okay, execution of next statement, is non-blocked. It will be non-blocked until the current statement is executed. Until the current current statement is executed. Statement is executed. Okay, and it will execute parallelly. It will execute multiple statements parallel. Multiple statements parallel. Okay. Suppose if we take synchronous counter, common clock is given, no? Common clock is given means what? Common clock is given means so all the flip-flop should trigger during the active transition of clock. So there, if you are using non-blocking means it will only one flip-flop will be activated. So if you are using, there we are using blocking assignment means only one flip-flop will be executed. If you are using non-blocking means all the flip-flops will be triggered. Okay, that is one example of non-blocking assignment. So mainly like for all non-blocking assignments in a block, RHS, right hand side, are evaluated first. Okay, so for all non-blocking assignments, okay, first the RHS, whatever the RHS value is there, RHS are evaluated first. Okay, evaluated first, okay, then Mm, then subsequently the specified assignment will are scheduled. Okay, whatever the assignment is there, that will be scheduled. Okay, assignments are scheduled. Okay, that means we'll discuss the Verilog event scheduler. So whatever the RHS values are there, that will be executed in the active region, and assignments will be happens in the non-blocking NBA region. Okay, that we'll discuss. Okay, and it is illegal to use non-blocking assignment in continuous assignment statement. Okay, so it is illegal. Okay, suppose when you try to use non-blocking in continuous assignment statement, in a continuous assignment statement, that is illegal. So we should not use non-blocking assignment statement in continuous assignment statement. Okay, assignment statement or in a net declaration. Okay, net declaration. So we can't use. Okay, suppose here we already seen continuous assignment statement, no? So here this is so we see in continuous assignment statement. Here we can't use. That means this non-blocking is illegal. Okay, we can't use. Compiler will give error. Okay, so this should be what blocking only. Did you understand? Yeah. So next here example. Let us take one example. I'm writing always at the rate passage of clock, always at the rate passage of clock. Begin. Let us take Q1 is non-blocking with D, okay, and Q2 is non-blocking with D2. Okay, mostly for designing sequential circuits, designing the sequential circuits, we use non-blocking assignments. Okay, we use non-blocking assignments. For designing the combinational circuits, we use the blocking assignment, and for designing the sequential circuits, we'll use the non-blocking assignment. Okay, that you need to remember. Okay, in the coding part also you can observe. Okay, and Q3 is non-blocking with D here D1 and here D2. Okay, and end module. Okay, end module. Okay. Uh, Now, one more is there, parameterized module. Parameterized module means we will discuss when we discuss the RAM design. Okay, now also we will discuss what is parameterized module. Okay, so parameterized module means what? Suppose when you design any RAM, okay, 8 cross 8 RAM, or when you design some 4-bit triple carry adder or 8-bit triple carry adder. Okay, so that means when you design, when you write the code. So the type is we can't open and we can't change the code. Okay. Sometimes what happens to the client or customer, he will ask, I don't want 8 cross 8 RAM. I want 128 cross 8 RAM, or I want 512 cross 8 RAM. Okay. I want like 16-bit refill carry adder. Okay. So there fixed code we can't write. So we can use parameters so that dynamically I can change the width, length and width. Okay. Did you understood where you are using parameter? Okay. So parameterized module means what? The module, the module in which, the module in which a parameter, is referred as parameterized one. Okay, it's referred as parameterized module. Okay, it can be done by using a keyword parameter. Okay, we need to use a keyword called, what the keyword you need to use? Parameter. Parameter. Okay, so example, suppose module, module example, module example. So you need to use a keyword that is hash. Hash means what? It's a parameterized module. Okay. So parameterized. So I am declaring parameter that is width I am declaring width equal to what 8. Okay, and next this is width equal to 8, and I am declaring that is input that is width minus 1 is to 0. Okay, that means what width equal to 8 means 8 minus 1. So input is what 7 is to 0. Okay, and what is output? Output I need to declare output width minus 1 is to 0 out. Okay, I need to use a continuous assignment statement assign out equal to what out equal to in. Okay, end module end module. This is one example of parameter, and one more example we'll see. Just this is the last example. So let us take. I will write the code for the counter using parameter. How to write the code for the counter? So I'm using that means mod 8 counter. Okay, mod not mod 8 counter, mod 7 counter. Okay, so dynamically I can change the mod of a counter. So I'm designing which counter means mod. So n equal to 7. So mod 7 counter. Yeah, mod 7 counter. Okay. So mod 7 counter I'm designing. Okay. So how to write module? Okay. What is my counter? Counter. What is my counter name? That means counter. I need to declare the ports. Okay. So clear, clock, and count. Clear, clock, and count. Okay. I'm declaring a parameter. So parameter uh, n equal to what 7, parameter n equal to 7, and input clear comma clock. Okay, input clear comma clock, and output I am declaring 7 down to 0. Okay, this is n. This is what 7 down to 0 means output I need to declare with reg data type n is to 0, that is 7 down to 0 count. Okay, and I'm using always at the rate negate of clock. Sensitivity list is negate of clock. Begin if clear count I need to clear with what? Count I need to clear with what? 0. Non-block what? 0. Okay. Else normal it should count. Count equal to what? Count equal to count count plus count plus 1. Count plus 1 and end module. Did you understood? So this is about the behavioral modeling. Tomorrow we'll discuss some sample codes related to this behavioral modeling, and you can work out this. So what we discussed means this is behavioral modeling. First we discussed about the structural procedures. Structural procedures, you have initial block and always block. Initial block will be executed only one time. Always block will be executed continuously. Multiple statements you need to write between the begin and end. Okay, we see in the example, so initial block and always block. Procedural statements means we see in the conditional statements like if else case, and looping statements like while, for, repeat. We have seen the syntax, and also we see in the examples also, and we see in one example of full adder circuit by using behavioral modeling. And types of assignments are like there are like continuous assignments and procedural assignment. Continuous assignment means all the inputs and outputs should be net data type, that is wide data type, and we need to use a statement, a keyword called assign and assignment statement. So basically this continuous assignment we are using in the data flow modeling. Procedural assignments means we need to use two types of assignments, those are blocking assignments and non-blocking assignments. So blocking assignment means when one instruction is executing, Next instructions will be in blocked state, and mostly for designing the combination circuits, we use blocking assignments. Non-blocking assignments means all the instructions. Non-blocking assignment example is suppose the two-line road is there, two-way, two sides vehicles will move. No? Is there any non-block blocking will be there? No blocking. No? That is exam. That like that you can remember. Okay. So all the instructions will be executed parallelly. Okay, that is non-blocking. Okay, two sides road is there. No, two sides. This side the vehicles will move. This side the vehicles will move. There is no blocking. So always that will be executed parallelly. Okay, concurrently. And parameterized module means like if you want to declare your size dynamically, you can use this parameterized module. So you can change within the design and text bench also. You can change the width depending on the customer requirement or client requirement. We see in the one example of counter and one more example we see. Okay. So is there any doubts or queries?